2212 Lab 1 on charged tapes. So as an introduction, some of the key ideas we'll cover are Coulomb's law, which calculates the force between two charged particles at rest, density, which is an idea that a substance's mass per unit volume. For tape in particular, which is what we use in the lab, it's 1 gram per meter. And then we'll also use Newton's second law, which states that a body at rest stays at rest until a force acts on it. Same with constant velocities. So here are some equations that we use. The electric force is equal to kq1q2 over r squared, which is Coulomb's law, and then F equals ma for Newton's second law. So our objective was to use tape in order to visualize the transfer of electrons between surfaces so we can estimate the net change in charge from those interactions. Then we wanted to use GlowScript to create a computational model that interacts similar to our pieces of tape, but in a perfect world which would neglect air resistance, friction, and other confounding variables. As a preview to our results, we found that the pieces of charged tape repelled each other because they were both positively charged. We found that the charge on each piece was about 1.529 e to the negative 8 coulombs, and then the number of electrons lost by the tape when they were pulled apart was about 9.5 e to the 10 electrons. So for some models and assumptions, here's our free body diagram, which you can see the force of gravity and the electric force completely cancel each other out, which is kind of Newton's second law there with a net force of 0. Some assumptions we made was that air resistance was negligible. We treated each piece of tape as a point charge with all of its charge concentrated in the center instead of across the entire piece. And then we assumed that each U-tape had the same amount of charge and that the charge was evenly distributed. So for the actual experiment, the system were the two pieces of U-tape that we used, and then the surroundings was everything else in the room. As you can see here, we charged the pieces of tape by pulling the U-tape off of the base tape, and then we used two pieces of U-tape down here to repel one away from the other, because like I said, we found that they were positively charged, so they repelled each other. And then for initial conditions, the two pieces of U-tape with equal approximate lengths and neutral charges, as well as two pieces of base tape to charge them. So for our observations, here's a few things that we found. The U-tape was attracted to my hand. We found that the two pieces of U-tape repelled each other. We found that the U-tape was attracted to a negatively charged object, such as a pen, and then the U-tape was attracted to a neutrally charged object, like a book. So as a conclusion, the U-tape was positively charged and lost electrons in the transfer process with the base tape. I won't go too much into my code because it'll be linked in the description, but basically we set constant values, we made a few calculations, and then we made our objects for our diagram that you can see here. So as some data, we found that the mass of the tape was 0.02888 kilograms, the length was 0.221 meters, the width 0.019, these are standard values. The distance between the pieces of tape was 0.0273 meters, and then the force due to gravity was this number right here, 0.00217 newtons. So then obviously we can tell that the electric force was the exact same, just in the opposite direction, because the net force was 0. And by doing that, we can see that the charge of the particle is 1.529 e to the negative 8 coulombs. As an overview in possible errors, we found this to be the gravitational force and the exact opposite to be electric force. The electric charge we found to be 1.53 e to the negative 8 coulombs, and we found that the electrons lost in the transfer was about 9.5 e to the 10. Some possible errors are that the unequal distribution of charges on the pieces of tape instead of focused in one spot. They're not actually point charges, but we assumed that they were to make the experiment easier. Not quite realistic. And then loss of charge due to handling, which we'll talk about a little bit here. Couple questions. What if electrons had positive charge, protons had negative charge? So we just inverse everything. This wouldn't change anything. Like charges would still repel each other, opposite charges would still attract, so there's not going to be much difference in the functionality of any aspects of this lab. It would just be exact opposite electrons and protons. And then why is it important to handle the charged tapes as little as possible? Well, when you touch the charged tape with like a neutral object, it wants to steal electrons over from there to replace the ones that they lost in the transfer between the U-tape and base tape before. So as much as you come in contact with the tape, it's kind of neutralizing itself out a little bit, and you get to a point where you don't have as many electrons that have been lost in that transfer, which I talked about a little bit in the possible errors. Thanks.